A microprocessor is the brain inside a computer. It's made up of a microchip on an electronic card. Preparing the chip to be installed on the card is a delicate and precise operation. Scientists built the first computer in 1937, but it could only do algebra. The first general-purpose computer in 1946 was the size of 20 fridges. During the 1950s, transistors replaced bulky vacuum tubes. Then integrated circuits replaced transistors. But the biggest breakthrough came in 1971 with the microprocessor. All the components on one minuscule chip, making today's personal computer possible. We start with a ceramic square called a substrate. This will carry the microchip. A machine coats the substrate's surface with flux, a chemical that makes it sticky. This will hold the microchip in place until it's soldered. This facility receives the microchips ready-made with all the circuits in place. A microchip is placed on each substrate. An infrared light guides the machine to place the chip in precisely the right spot. A sample is pulled from the production line to further verify the positioning with a microscope. Next stop is the soldering oven at 360 degrees Celsius. The heat melts tiny beads of tin positioned on the chip, binding it to the substrate. Next they prepare to solder an aluminium cap over each microchip. The cap has two functions: to protect the chip and to dissipate the heat the chip generates. A robotic arm picks up 4 caps at a time and positions them over the microchips. They go into a soldering oven at 150 degrees Celsius for about an hour. The next step is to create the electrical connections that will later link the microprocessor to the computer's electronic card. They start with tiny cylindrical pieces of tin called columns. A giant suctioning sieve vibrates the columns until they fall through the holes. This lines them up vertically so they can be attached to the substrate. A thick adhesive paste is spread that attaches the vertical columns from underneath. The chip-carrying substrate is positioned on the pasted columns. The result is a microchip with 1,000 connections. For even more connections, tin balls are used instead of columns because balls are sturdier and more reliable. They too go through a suctioning sieve. Only instead of paste, they're stuck on with flux, the same sticky chemical used earlier to position the microchip. The finished microchip unit goes into a bath of water and solvents to remove any excess flux and contaminants. Last stop is quality control testing, including 12 hours spent in an oven heated to 140 degrees Celsius. From here, the microprocessor unit goes to another factory where it's soldered onto an electronic card. The little brain is then ready to get to work.